guys, so 1.1. We're jumping into polynomial characteristics. So polynomial functions, what they look like. So first, let's just look at what a polynomial is. Like, what are the requirements for something to be a polynomial? The exponents have to be whole numbers. So exponents are whole numbers. And when you look at the graph, it'll be smooth and continuous. Graph. So guys, whole numbers, that's like 1, 2, 3, 4. Okay, you can't have fractions as your exponents. You can't have negative numbers as your exponents. Just normal 1, 2, 3, 4 for your exponents. And then the graph is smooth and continuous. So what I mean by smooth, it's not going to have any like sharp points. So an absolute value graph is not a polynomial. Okay, it just has to be like the nice curve. That's what a polynomial graph looks like. Continuous, it won't have any asymptotes. There's no jumps, holes, anything like that. Just one continuous graph. So let's look at one here. I'll give you f of x is equal to 3x to the 4th plus 2x cubed minus 7x squared plus 5x minus 1. Okay, so let's talk about a few different parts of this. First, the degree of the polynomial. Any guesses? What's the degree of this one? Are you raising your hand or going like this? Yeah, it is 4. So when it's written out like this, this is called standard form, where you have all your terms, you don't have any factors. All you're doing is looking for the highest exponent, and that is your degree. So in this case, the degree is 4. All right, do we know the leading coefficient? I think I heard it already.
3.
Yeah, 3. So the term with the highest exponent, whatever the coefficient on that is your leading coefficient. All right, for this polynomial, we want to know what the constant is. You guys can just say it. What do you think? Close. -1. Okay, yep, take the sign that's with it. I heard 1 and -1. It is -1. So it's the number that doesn't have a variable with it. That's your constant. Okay, so -1. All right, and then part D, possible number of turning points. So on a graph, a turning point is when it changes direction. So like increasing to decreasing, to increasing to decreasing. That's a turning point. This is related to the degree, but it's not equal to the degree. Does anybody remember?
3.
It's 3, yes. It's always 1 less than the degree. And it doesn't mean you have 3 turning points. It means that's the most you could have, okay? So this is 1 less than degree. Okay, familiar from Algebra 2, guys? A lot of that? Okay, coming back slowly. All right, let's talk about a couple of other things. Not this graph specifically, but just graphs in general. We want to know what an x-intercept is. What can you tell me about an x-intercept? Do we know anything about an x-intercept? Yep, it's when the line crosses the x-axis. And what is your y value when you're on the x-axis? 0, yes. So an x-intercept is always when y equals 0. And what do we think a y-intercept is? Yeah, when x equals 0, right? So that's where you're crossing the y-axis. That happens when x equals 0. We'll need both of those pieces as we try to graph polynomials, okay? All right, next one, multiplicity. You might not remember much about this one. Is the word familiar? Yeah. Do you know how to define it? Or are you like, I've heard it, but I don't really know what to do with it? Kind of. It definitely has to do with the factors. It's when the factors happen more than once. So if you have like x plus 3, that quantity raised to the 3rd power, that has multiplicity. Okay? So when the same factor repeats is how we'll talk about multiplicity. And then there's 2 kinds of multiplicity. We have even multiplicity. What this does on your graph, it creates a bounce, like your graph is going to bounce off of the x-axis. If you have even multiplicity, think about a quadratic, right? It comes down to the vertex and then turns right around and goes back up. The technical term is point of tangency, but I know what you mean if you say bounce. So even creates bounce, or point of tangency, and I'll draw you a picture. So So your graph would come down, touch the x-axis, and then bounce and go right back up. Okay? That's what even multiplicity does. You can also have odd multiplicity. And that one creates a point of inflection. Anybody know of a graph that has a point of inflection? You guys know your cubic graph, right? Like the squiggle graph. Right in the center there, that's a point of inflection. It's where it changes from concave down to concave up. So that's what a point of inflection looks like. Sketch form. So it doesn't just cross your x-axis with a nice straight line. There's that little curve to it in the middle there. Okay. Any questions so far? I'll make sure everybody's caught up, and then we'll do an example where we're going to graph these. Okay? Okay, our function here, we're going to do f of x equals x minus 1 quantity cubed times x plus 2 times x plus 4 quantity squared.
What about the one we did earlier with the 3x?
We're not going to graph that one yet. Factored form is much easier to graph a polynomial than in standard form. So we're going to start with this one. So this is all non-calculator, guys. We're just going to figure out all the different points that matter on this graph without a calculator. So we're going to think about a lot of different things here. Oh, sorry. Do you need me to go back? Yeah. Guys, if I ever go too quickly through something, or you can't read my handwriting, anything like that, just say, hey, what was that?
Already, I'm good.
Okay. Okay, so when you're graphing, there's kind of a series of pieces that we need to find, and then we can create the graph. So the first one, we need to know what is the degree of our polynomial. So it's not in standard form this time, so you have to think a little more about our degree. No, you do not have to multiply this entire thing out to figure out what the degree is. Please do not do that. You will be multiplying forever. Okay? It will be very ugly. All you have to do is look at the individual degrees of the factors and add them up. So I see a 3. What's written on that second one, even though there's nothing there? 1, okay? So I've got 3, 1, and 2. So combined, what do I have? 6. So the degree of this polynomial is 6. Okay. This is telling me about the end behavior of my graph. what do we know about even degreed polynomials? What do the ends of the graph do? I see this, some hand signals. Yes, both ends are going up, right? If it's even degree, they're going to match. They're either both up or both down. I don't see any negatives out in front of this thing, so they're definitely both up. So that's the first sort of little piece I'm going to draw on my graph. I'm going to just draw two little arrows. That's where I know the ends of this graph are going. That's all I know so far. All right, my next piece, I want to find the x-intercepts. Okay, these come from the factors. So there are 3 x-intercepts here. What do you think they are? What do we got, guys? Don't be shy. Go ahead. Sure. I'm sorry, I'm still working on names, guys. So this is the awkward, you think I'm looking at you or not sort of moment. -2 is one of them, yes. So -2, 0, that's an x-intercept. What else? Yep, 1, 0. And? Yes, good. -4, 0. So you just take each factor, set it equal to 0. That's all we're doing. Okay, you don't have to show work for this. You can do that in your head easily enough. So I'm now going to plot those 3 points. So -2, I'm going to just put a couple tick marks. There's -2. 1 and -4. Include the tick marks so we can see, you know, where we actually are on the graph. Okay, with those, I have some multiplicity that I need to deal with. The -2, 0, since I wrote them in this order, does that have any multiplicity? It's just to the first degree, right? Okay, so nothing weird happens there. What about at 1, 0? What kind of multiplicity happens there? It's odd, right? The degree is 3 on that factor. So that means I know I'm going to have like this little squiggle going on at that one, okay? What about at -4, 0? What kind of multiplicity is that? Even, okay? That's where it bounces off the x-axis. That's a point of tangency. So just watch me draw this, and then you guys can do it on your paper. I start at the left side and just work my way across the graph. So I know I'm starting, I've got that arrow over there, and I've got to come down to that first x-intercept. So I come to -4, but it has to bounce off of the x-axis there, so I must come back up. -2, it just goes straight through, so I just draw my line straight through. I'm not sure what the y-intercept is yet. I don't care. And then I do the lovely point of inflection there, and I move my arrow over because I was a little off. That's what my polynomial looks like so far. Does that make sense? Like one little step at a time. Each x-intercept, figure out what's happening. We okay to this point? Okay, but one last thing we need to find is our y-intercept. Okay, what did we say up above about the y-intercept? It's when x equals 0. So that means I need to plug 0 in for x to figure out what this is. So I need to do 0 minus 1 cubed times 0 plus 2 to the first times 0 plus 4 squared. So what's -1 cubed? negative 1, okay. And then times 2 times, what's 4 squared? 16. So when I multiply that all out, what do I get? Yep, so the point 0, negative 32 is my y-intercept. Okay. Do you really want to put like 32 tick marks on your graph here? I do not, no. So I'm going to put the dot, and I'm just going to say, hey, that's where negative 32 is. And I just label it, and you're good. You might have a y-intercept that's like 350. Great, just put a dot and say that's 350, and you're good. Okay, you just have to acknowledge where it is, and that's all I need. So that's how you graph a polynomial. Just do it one piece at a time. Questions on that one? We're going to do several more of these to make sure we've got it. Anybody need this up for more? I'm going to switch slide. We good? Okay. All right, your function is x plus 3 squared times x minus 4 cubed. All right, you guys are trying this one. So I'll give you a minute here. Go through the same steps. Degree, x-intercepts, multiplicity, y-intercept, okay? You can talk to each other. Work together on it, guys. Talk to each other. Are you on the right path? Or are you on, at least you agree on the path you're on? Okay, so did you get your degree? Okay, good. So, good start. All right, that's odd, right? So do you remember end behavior? Odd ones look like that. Okay, so that's what, let me draw a quick end behavior. Actually, that's really
So last
messy.
you said 9 and is it negative 64?
It's 9 times negative 64.
Right.
So this is just a big number. Hey guys, I'm going to put up here just a little reminder on end behavior. in case you've forgotten. Is end behavior familiar to you guys? Just maybe need a little memory jog on it. Okay. So that's what you should be visualizing, if it's even or odd, and then positive or negative leading coefficient. Okay. I'll give you another few minutes to work on your graph.
Yes.
You got it? You think? Okay.
Is there any point to the dashes? Do we need the dashes?
On that?
Like for this one, or like you would do it like that?
Why did I go like that? No, I don't care.
It doesn't matter.
No. Degree is 5. Did I do like a colon before maybe? Or whatever it is.
Oh, yeah. Yeah. So like this.
That's because
Is it like supposed to be like this?
well, this one down here. 6 degrees, so if the degree is odd, the ends are always going in the opposite direction. If it's odd, the leading coefficient. It has to be even degree for them to match. Okay. Okay, so similar issue. So degree is 5, right? So do you see how you kind of like created an extra exception there? That's because you were trying to make it fit the behavior that it is. So like this side, yeah, this end's definitely up and this end's down.
Oh, so it's not like same.
So it's gonna bounce.
Okay, and how would you something else?
Like from here. It's like find the degree. Okay, it's odd. Like even though I don't know what else is happening. This side's down.
So
Kind of like being
so
so
when the
starting
degree is
here.
okay, so the degree is odd, then there's gonna be like that.
If there's a negative in front, that's this side's up. This side. Oh, they'll all be okay. Odd and opposite. Which makes sense because you're down here. So. You're on the right track. The y-intercept is fine. It should be down here. And then the bounce reflection is there. So you like switch it around. So very good. Oh Just the number, okay. Again, guys, we're doing a bunch of these, don't worry.
And then you got to what is 0 plus 9, 0 plus -4.
Yes.
So yeah, so you add up the second reading is 4.
Then you have to do
-5 is 7, yeah, and that's all the way down here.
yes, so what did that?
Yeah, I guess nothing else. And then it goes from up here, from
Yeah, I'm paying attention. Make sure you're paying attention.
and then you go up here,
What is it?
it's down. Oh, wait, no, it doesn't. It is.
Okay, guys, let's go through this one and then we'll practice more. We'll see how we're doing. If we're stuck anywhere. Okay, degree is 5. Odd degree, they go opposite ways. If it's positive, the right side is somewhere up here and the left side is somewhere down. Okay? All right. Your x-intercepts. We only have 2 of them. We have one at -3, 0, and 4, 0. So 1, 2, 3, put a dot. 1, 2, 3, 4. And I like to draw the whole graph and then go back and figure out my y-intercept because I'm just going to label wherever it was anyway. So I need to look at the multiplicity on these 2 x-intercepts. The -3, 0, that has even multiplicity. That's from that exponent up there. What does even multiplicity do? What does it make happen? Bounce. So I start down here at my end behavior and I bounce. I figure I got to get over to this other point somehow. What kind of multiplicity does that one have? Odd. What does that mean? Point of inflection. Yes, weird squiggle. And guys, if you struggle to draw the inflection, like sometimes it's hard, like it's just tricky sometimes, or if it's from the opposite direction, I find those even harder. Just like put a little arrow, point of inflection, like letting me know, okay, I know this is a point of inflection, I just don't draw well. It's okay, I'm not testing your drawing abilities here. So point of inflection, and I'll fix my arrow. Are we okay with the shape of that one? Okay. Y-intercept is when we plug the 0 in, so that's really 3 squared times -4 cubed. So 9 times -64. What do we get for our y-intercept, guys? Yes, -576. Anybody still putting tick marks on there? We just say, hey, there we are. And that's your graph. Okay, we see the process? Okay, let's try again. I'm going to add a small wrinkle for you. Just a small one. All right, this time f of x equals x cubed minus 2x squared. What's different about this one? It's in standard form. So what do you think we need to do first? Factor. So it's good you guys are good at factoring, right? So factor it, and then you go through the same thing. Okay, degree, x-intercepts, multiplicity, y-intercept, all that stuff. So factor first, try to sketch that one. You sure can, yeah. If you want to get the degree from standard form, that's easy, right? It's just the biggest exponent, so you can start there. Sketch your graph, chat with your neighbor. Do you match? Do you agree? Did you get it? You're stuck. Yes, if degree is 3. So what are your ends doing? One is it? Yeah, okay.
Wait, degree is 3.
Okay. Is this in factor? So if it's in standard form, it's just the highest degree. If you factor it, then you can do the counting of the exponents, okay?
So for the third one, when it was x plus 3 squared, x minus 4, you just add 2 plus 3.
Yes. Yep, exactly.
You get the x steps. Like, I know I didn't do the one.
Did you factor it?
Yeah.
Okay. So you set each factor equal to 0. So this one we got. Well, then that's 0. It's the easy ones that always there's only one.
But you factor that one. You would take that, or you just factor this one. Then you would go, I don't know, would this just be 1? One.
What is happening? Okay. So, end behavior. So you're going to want to start with, you know, this side has a little arrow down here. This side has a little arrow up there. So draw those. Don't connect anything yet. Just draw a little arrow. Okay. So we always start down here. So I come up to this first intersection. Does it have multiple? Okay. Oh, so it's not wrong. So it needs to bounce off of the x-axis. So like, pretend this is a ball. Just throw a ball against the x-axis. It's not going to go through.
So if it was like this,
and actually, it should be a little curvier. That's how it is. Okay. So, did you factor that?
I'm not sure.
That's way too many things.
I mean, it's not just if you're driving.
Yeah,
If you multiply this
but I was like,
Yeah.
so I made an actual.
Oh, that's X squared.
Yeah.
Honestly, I do. I just don't. Apparently, I don't like that. Or I just don't say that. I don't say the word. Okay. She'll say, "I forgot your little brother at the mall." So I don't have a little brother. Or a little man, or kill my puppy. That's what she says. You create a scam, you kill them. And I like orange sugar, so she'd say you just kill the little animals. So x squared. So then you do x.
Yeah, so now what are your two x-intercepts?
Minus 2. So it would be, oh wait, but because you wouldn't do anything with this, you would do what?
And it would just bounce off.
Oh, so it would be like x squared. No, but then you just do,
What would make it 0?
you just cancel if you divide it.
What x value makes it 0?
What x value? I don't know.
Okay, what x value makes this 0?
How does this become 0? Because you just plug it in. Like you're saying x.
Finding your x.
Oh, you're saying like 0 squared. Why do I make things so complicated? Just like, okay. So it would be 0 and then 2.
Yes, those are your two x's.
If we don't have, we only have one? It would be 2 x's. 0, 0, 0, 2. Honestly, I feel like I'm crazy.
I was gonna say
I was like, huh? It's always, like, that just always happens. Like, I'll try to do the craziest shit. Okay, that's fine.
Okay, oh, that's second for that consideration. What about the section? Okay, what would you like?
I think it's just
0, 0, 0.
You know what I'm saying?
that was amazing.
0, 0.
I think you plug in the things and everything, so it would just be 0 and then 0 times -2. That's negative 0. Like, hey, it's like, that's still like a 0, but now I plugged it into this. There's 2 that's
You would play it to the original.
cool.
Right.
I got 0 from this.
So we have the 0, 0.
I like that.
So I don't know how it's still then 0, 2. So how do we get How would you get that? Oh, it's 2, 0. Wait, no, it's not. 0. Oh, no, you always put it.
My brother didn't
I think it was 0, 0.
0, 0,
And then we'll put 1.
so it would be 0, 0.
Did you say you have to district?
Miss John.
Oh, you missed job. What are you taking? Oh, great. You like add
I like to miss my brother.
She's goofy.
She's just like,
Yeah, she doesn't all that. Oh my gosh, she talked to her son. Did you see a picture of him? Yeah. Did she go around the class? Okay. And around the photo? Okay. Good job, factory. That's a good last year, sir. So, what are your subjects? Good luck on the AP exam. Holy shit. When I tell you that it was 0, 0, it was tough. And then you already have I definitely struggled on that. Alright, what's your name? Yeah, the Catholic Q, BBQ, I still don't really do it well. At the end of the class. I also didn't evaluate my class. Well, I still don't do it today, but like I think it's a very easy class. Yeah. She does a lot of yeah, she gives it to you. Depends. If you really want to do well on the AP exam, which would help, then you're going to want to do reading. The reading does help. Oh, also, since the shit was no retakes, we should save my stuff. Like, I don't know what I would have done if it's just not retakes. Okay.
Yeah, these tutorials are like that.
At least they're doing replacements. I feel like honestly replacements are better because that way you don't have to practice studying.
They're different.
But we're not going to do it in California. Alright guys, let's go back through this.
It's nice though that like if you just like learn it a little
Still live up here,
you won't fall behind.
Okay.
Because you're just you don't really have to worry about it.
My computer's not alive.
And it's also nice that if you do worse that it doesn't like replace it if you do worse. That would suck.
The automatic replacement.
Yeah.
Yeah.
If you bombed one test or all the places.
Okay guys, let's go through this one. The degree here, it's 3, okay? You can look at it in standard form and just get the highest exponent. You can look at it after you factor if you wish. It's easier to see it in standard form. Odd and positive, I know one end is up, the right side's up, and I know the left side is down, okay? I'm going to factor this so that I can find my x-intercepts. All right, so I have 2 of them. Most of you were like, okay, 2 is one of them. You are correct. Don't overthink the other one. When you have just an x or x squared out in front, your other x-intercept is just 0, 0, okay? That also takes care of your y-intercept. So then it's just a matter of the multiplicity. I know the 0, 0 is the one with even multiplicity, so I'm going to start on the left end. I will bounce off that point, and then I just cross straight through on that one, okay? There's no inflection. I know technically 1 is an odd number, but it's called multiplicity because of multiple factors. 1 is not multiple factors, okay? 1 is a single factor. So it's only like 3, 5, 7. That's when you have the inflection point, okay? All right, let's do one more before we finish up with getting logged into delta math and all that stuff, okay? One more graph here. Anybody questions on 4 before I go on? I got to most of the room. I didn't get over to this side. Were you guys okay over here? Okay. So this one, f of x equals 2x cubed minus 7x squared minus 4x. Before you start factoring, because yes, you have to factor on this one. What is the degree? 3. What does that mean for your ends? Yeah, that's right. 1 up, 1 down. So I know this much right away. Now try to factor so you can find your x-intercepts. Okay, Lauren, did you take out a GCF on this one?
Huh?
Did you take out a GCF when you were trying to factor this one?
Did I try to?
Yeah.
Yeah, I would take out the x.
Okay, good job. GCF has not been your friend today. Okay, you're close. So you took a 2x out of this, right? You would really take it on that. It wasn't right. So really,
And then I shut x and so and 0 0
you're factoring, yes, good. You've got your 3. That's right. It is negative 1.
Okay.
Yep. And there's no holes. So you don't have to worry about bouncing or inflecting or
Just go straight through.
cross, yeah. You have to factor, yes, good start. Plus, you give you negative 8, that's a 27.
Oh,
Kept that leading focus.
almost went to say later.
Let's see. Yeah, try to make this like a little more like, so you can should almost be
Oh, sure. Okay.
right here, because like I'm a couple of you have to do that.
Okay.
Got it. Graph polynomial. Yeah.
Yeah, I think it's 0, 0, 15.
There's only one of them. Yeah, so 2x, oh, then equals 0, and minus 1, minus 1, negative 1 half, negative 1 half, 0. Where did you get the 0 from?
Because you have to like exit the
Did you have this or do you really? Okay.
So you go through it, they go back through it, 0. All right, guys, I want to make sure we have time for the last little bit here, so let me go through this real quick. All right, we need to factor, so I can take out an x. And then, guys, factor with a leading coefficient, grouping, guess and check, whatever you do, you should have ended up with x times 2x plus 1 times x minus 4. Okay? So your x-intercepts are 0, 0, negative 1 half 0, and 4, 0. Do I have multiplicity on any of those? No. Okay, so they just are. So negative a half 0, 0, 0, 2, 3, 4, 0. So what this means, this guy. You cross the x-axis, you cross the x-axis, you cross the x-axis. Physics. And you already found your y-intercept because it was 0, 0. We're going to keep practicing this, but I think you guys are doing pretty well with the process, right? It's a lot of pieces, just do them one at a time. Okay, what I need you guys to do, there's two things. On Schoology, there's a couple of updates for you. You should see one that is about filling out a getting to know you form. It's just a little Google form that I need you to fill out for me. And then the other one is the information on how to log in to Delta Math. I'm going to assign a homework to you right now in Delta Math, so there should be one waiting for you.
So we run off to have paper or not?
Sometimes, but not very often. More often than not, it'll be Delta Math. If you're having issues with either link, let me know. Or if you get into Delta Math and you don't see anything, let me know. There should be a 1.1 homework assignment waiting for you in there. Yeah. Oh, yes, thank you. Yeah, that works. Thank you. Have a good one.